So in the previous video, I mentioned that atom is the basic unit of matter. All the matter is made of atoms. However, atom is not the tiniest, the smallest unit. Inside the atom, there is still something. And in this video, I'm going to introduce you the atomic structure. So atom is made of, so all the matter is made of atoms, but atomic structure has the nucleus in the very center, and there is electron clouds that's around it. So all the atoms is typically made of, you're going to have at least a proton inside the nucleus and an electrons cloud. So nucleus inside is the core of the atom, has the neutrons and protons that's in the nucleus. And there is an electron cloud that's surrounding, that's making up an atom. Let me share the screen again. Here. So here is the atomic structure. Atomic structure. Inside the atom, you have, let's imagine this is very basic atomic structure. So we have something that's called nucleus. In the center. And inside the nucleus, you're going to find smaller particle that's called protons and neutrons. All right. And around the nucleus, you have this E minus is the electrons. So atoms are made of electrons, protons, and neutrons in the nucleus. For example, let me see, this proton and a neutron, electron, that's making up an atom. Let's compare the size by mass. So proton and neutrons are about the same mass. It's 1.7 times 10 to the minus 27 kilogram, both of them. However, electrons is a lot smaller. It's about 10 to the minus 31. It's about 10 to the minus 30 kilograms. So these protons and neutrons compared to electrons, they are 2,000 times heavier than electrons. So what the atomic structure looks like is that you have a very heavy, dense core in the very center that's making up a nucleus by protons and neutrons. And then around it has a very light electrons cloud that's making up a space of the atom. So atomic structure is pretty empty. Although it may have a size of 10 to the minus 10, but then it's pretty empty. And then at the center, you have a very dense structure. That's a nucleus. I can show you the slide here. So this is atomic structure. The one We have different kind of atoms here though: hydrogen atom, helium, lithium, and aluminum, let's say. And typically the one that I just showed you is the typical look of the atomic structure. And you see there's a nucleus in the center, and inside the nucleus we have there are neutrons and protons. And as you notice that you see the positive, that says the positives are the proton. The particle that has the positive side is a proton, and then the orange looking thing is the electron that's surrounding the nucleus. And the orange looking thing has a negative sign. What it means is that a proton has the electric charge that's positive, and neutron do not have any electric charge. And electrons has a negative electric charge, which is the same amount as the proton in magnitude, but in oppositely charged as proton. So the positively charged proton, but then the mass is a lot heavier than electrons are in the nucleus, and then the neutrons, that neutral, electrically neutral, but same mass as protons, are both are in nucleus, and then negatively charged, very light particles, that's called electrons, is making up a volume of the atom. So atom is the basics of units of matter, but inside the atom there are smaller particles that's called electrons, protons, and neutrons. Are these the fundamental particles then? Are these it? Are these the smallest particles? No. So it actually, in fact, electron is the smallest particle, fundamental particle, but protons and neutrons are not the fundamental particle. Sorry, I should mention this. But before, yeah, I already talked about this, but proton has a positively charged. And then again, where is it located? It's located inside the nucleus. So is the neutron. Is neutron has any electrical charge? No, it's neutral. And where is it located inside the atom? Inside the nucleus. Electrons is also making up an atom, and the electron has what kind of a charge? Negative charge. And where is that located inside the atom? It's around the nucleus. So, and then I mentioned that, yes, actually electrons, we mentioned inside the atom, we have a smaller particles, electrons, neutrons, and protons. But still, they're not, those three particles are not necessarily the fundamental particles, the electron is. But the proton and the neutrons are not the fundamental particles. Oh, I'm sorry. Keep talking about it. Sorry about that. I already mentioned about this in the slide, in the note, but proton and neutrons have about the same mass. That's 10 to the minus 27, 1.7 times 10 to the minus 27, and electrons is about 10 to the minus 30 kilogram. So to compare the sizes, I mentioned that a proton and neutrons are 2,000 times heavier than electron. But that's something that you can imagine. It's about like you have a penny and compared to the bowling ball. That's how much the different in the mass. That's how significantly different. And as from here, you must be able to see that I mentioned that electron is a fundamental particle and protons and neutrons are not. So atomic structure has this nucleus, and inside the nucleus, we have neutrons and protons, right? And these neutrons and protons are a lot heavier than electrons, and they're not fundamental particles. They are made of smaller particles that's called quarks. So quarks, leptons, they are the fundamental particles. That's it. There's nothing that's smaller than that, we think. It's always a challenge to go farther and farther, but so quarks. What is quarks? What we see is the almost the standard model of fundamental particles, and this is actually not the case anymore. This is actually an old idea, but we're just going to stop it here. We're not going to go talk about the anti-symmetry and all that stuff. But here is the quarks, the picture of a quarks and the leptons. So you see the purple blocks. These are the quarks. And then the green blocks, they're called the fundamental particle. That's called leptons. And you see that electrons are part of leptons, right? And there's a leptons, electrons is, let me see. You know what? It's okay. So electron, I wanted to show you differently. Maybe I still can. Let me stop it for a moment. Let me stop. All right, so let's see from here. This might be better to explain. I'm trying out new thing here, so please bear with me. Okay. So I mentioned that protons and neutrons are not the fundamental particle an electron is. So electron is a fundamental particle. Protons and neutrons, which is a lot heavier, are made of smaller particle that's called quarks. And here is the picture of a quarks, the table that I was just telling you about. I believe I can do this. So as you can see here, the electrons here is in a category that's called leptons. And these green ones is all leptons. So purple one and a green one, these are the fundamental particles. And you see over here, it has the 0.511 mega electron volts per c square. This is the electron volts is the energy divided by c square. So you might have heard the equation that's called E equals mc square, which describes the mass. So the bigger the energy has means that it's the bigger the mass, right? So you can see that tau here has the 1.77 giga electron volts per c square. So this is heavier than electrons. So you can see the tau is heavier. So it could be a little more unstable, that it can decay. So tau becomes muon, muon becomes electrons possibly. And when they're decaying, they emit these neutrinos and things. And then you have to do all this conservation of the spin and all that stuff. But anyhow, and conserving of energy, momentum, they're all important. Angular momentum. Anyway, so anyhow, this tau is a heavier lepton than electrons. And electrons, as you can see, is the smaller of all the this tau compared to tau to muon and electrons. That's why electrons is abundant in nature. That's why the atom is made of electrons. Atom is not made of tau, right? It's not made of muon. It's made of electrons. It's because of that. So it has a tendency. So I hope you can understand this diagram a little bit better. Okay, so that's where the electron is. The electron is a fundamental particle that's in the group of leptons. And then in the leptons, there's a pairing particle that's called electron neutrino. And for muon, you have a muon neutrino. And a tau, you have a tau neutrino. And these neutrinos, actually, they do not have mass. They don't have mass. They don't have any electric charge. They don't have mass. So no mass, no electric charge. So it was very, 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 very hard. You can't observe it. We could be getting a shower of a neutrino right now through our face, but it's because there's no mass and no electric charge. It doesn't interact. It's just passing through, penetrating through without making any interaction with us, with any matter, right? So these neutrinos can be there, but it's very hard to detect. However, though, we did prove that I said no mass, but we did prove that there is a mass. Tiny, 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 tiny mass. That it's there. We still cannot prove how much it is, but there is a mass. That's how much we got. But that was a big thing, and yeah, in particle physics. So we proved that there is a mass, and we said oscillation, but anyhow. So these are the neutrino pair that's in the lepton category. And then the purple one is the quarks. There's the up and down. This U and D is the up and down, and there's the charm and strange, and there's a top and bottom. And again, that you see the up and down is lower in mass, and then the charm and strange is the higher mass, and then top and bottom is the bigger mass, right? So there's a mass, gets heavier and heavier as you go to the right from left. There's a charge. For leptons, you see that electrons has a -1 and muon has a -1 and tau has a -1 electric charge. Interestingly, up, charm, and top has the electric charge that's positive 2/3. And then the down strange bottom has the electric charge that's -1/3. So that's the charge that it has. I mentioned that protons and neutrons are made of quarks. So let's see. Neutrons, so from here you can imagine that neutrons and protons are most likely made of what kind of a quarks? So there is a particle that's made of quarks that's called baryons. The baryons are made of 3 quarks. And then there's a mesons that's made of 2 quarks. Both neutrons and the protons are baryons, so it's made of 3 quarks. And all these things you don't need to memorize. I'm just telling you as a side and things. But anyhow, so neutrons and protons are made of 3 quarks. And we know that, for example, we see neutrons and protons are making up atom. So it must be made of stable quarks, right? So it's most likely made from up and down. And neutrons are made of 3 quarks, and it's up and down. So, and the neutrons have no electric charge. So from here, we can kind of see that, okay, maybe neutrons are made of up, down, down. So 1 up and 2 downs makes that to be electric charge is 0. So on the other hand, if we have 2 ups and 1 down, that would make up to be positive electric charge. So proton is made of 2 ups and 1 down. So something like that. So you can see that, and then this may explain why the protons and neutrons are heavier than electrons too, because they're made of smaller fundamental particles that's called quarks. All right. So that should be enough for this video. And sorry I mentioned too much about the quarks and the things, but that's just on the side. But I want you to know, how much I need you to know is the atomic structure. How's the atomic structure looks like. And also want you to know that electron is a fundamental particle. Proton and neutrons are not a fundamental particle. There are fundamental particle that's called quarks. All right, so that's the end of this video. See you at the class.